2025 major paper 42. Let's take a look at the question number 1. A crate is being pushed in a straight line along a horizontal force surface by a force of magnitude 25 Newton, inclined at 20 degrees above the horizontal. The crate moves a distance of 12 meters in X seconds with constant speed. Find the constant speed of the crate. So the constant speed of the crate is actually the distance divided by time, 12 over 8. So you will get this one as a 3 over 4, 3 over 2 meter per second. That is the answer for question number 1A. Move on, 1B. Find the work done by the 25 Newton force. So the work done is actually the 25 cos 20 multiplied by 12 meter. Okay, the reason is because the crate is being pushed with a 25 Newton in such a way that is 20 degree above the horizontal. So you need to resolve the force into horizontal first and then multiply by the distance traveled horizontally. So this answer will be 282 joule. In terms of 3 significant figure, mention that is a highlight that this is a 3 significant figure. So you'll get 282 joule. Okay, now we move on to the question C. The power at which the 25 Newton force is working. So the power is actually the force multiplied by the velocity. So just now the force is 25 cos 20 degree. And from the part 1, we know that the velocity is 3 over 2. And just press the calculator, you will get this one as 35.2 watts. Done. This will be the answer for number 1C. Moving on, we have question number 2. Measures 0.2 kg and 0.1 kg respectively are free to move in a straight line on the smooth horizontal plane. P is projected towards Q with a speed of 5 meters per second. After the same instant, Q is projected away from P with a speed of 2 meters per second. When P collide with Q, the particle coalesces. Find the KE loss during the collisions. Okay, so over here, maybe we can draw a diagram. So this is a 0.2 kg for the particle P, 0.1 kg for the particle Q, and they are moving in the same directions. The P is moving with a speed of 5 meters per second. This is moving with a 2 meters per second. Okay, then after that they coalesce. Coalesce means they share the same speed. So we just use the conservations of momentum. So we will be having the MUP plus MUQ is equals to the MP plus MQ, the V. So just press a calculator, you will get this one as the 4 meters per second. Okay. So the KE loss is equals to the KE at the very beginning for the P and the KE at the very beginning for the Q minus the KE in the end. It will be 0.2 plus the 0.1 of the 4 square. So over here, you will get this as the 2.5 plus the 0.2 minus the 2.4. Press the calculator, you get 0.3 joule. This will be the answer for the question number 2. Moving on, we have question number 3. Over here shows a particle of mass mkg attached to one end of a light inaccessible string of length 2.6 meter. The other end of the string is attached to a fixed point O on the horizontal ceiling, and the string is taut. The particle is held equilibrium by a force of magnitude 35 Newton acting in a vertical plane which is perpendicular to the ceiling and contain the string. The force acts in a direction perpendicular to the string. The tension of the string is T Newton and the vertical distance of P from the ceiling is 2.4 meter. Find in any order the value of M and the value of T. Okay, so these questions we actually need to reconstruct again the diagram. This is the tension. This is the 35 Newton. This is the weight. The weight is mg. So over here, we need to have angle. So maybe we will choose this as the angle theta. So if we choose this as an angle theta, then actually we can draw a vertical line over here to form a right angle triangle so that we can find the theta. So at first, we're having this as a 2.6. This is the theta. This is 2.4 meter. So we have a sine theta is equal to 2.4 over 2.6. That is equal to the 12 over 13. So from here, we can build a right angle triangle. 12, 13, and 5. Okay. So that means if you let this as a theta, then this will become the theta, and this will become the theta. If you resolve the forces vertically, you have a d sine theta plus the 35 cos theta is equal to the mg. So sine theta is a 12 over 13 d plus the 35 multiplied by 5 over 13 is equal to the 10m. So we can have 12d plus the 175 is equal to the 130m. That will be your equation number 1. Now I resolve the forces horizontally. I have the 35 sine theta is equal to the d cos theta. So actually the d is equal to the 35 tangent theta. Tangent theta, you refer to the right angle triangle, you actually have 12 over 5. That will be 7 times 12, 84 Newton. Okay, so if you put into the equation 1, you have a 12d plus the 175 is equal to the 130m. Okay, I need to spare some space over here. It will be 12d plus the 175 is equal to the 130m. And then just use the calculator, you will get your m is equal to the 9.1. Done. This will be the answer for question number 3. Now we move on to question number 4. Traveling along a straight horizontal road, the car passes through the point A on the road, traveling at a speed of 15 meters per second, and then accelerate uniformly over 0.4 meter per second for 30 seconds. And then after that, the car is moved at a constant speed for 3 seconds, where the t less than 30. And then we have another stage over here. The car then decelerate uniformly at 0.2 meter per second square. And then after a further 30 seconds, passes through the point B. Okay, so we have 3 different stages over here. So we need to calculate the stage 1. Stage 1, you are having a 15 meter per second over here. You are accelerate for 30 seconds. Then we need to calculate this value. So to calculate this value, we just need to use a formula V equal to the U plus AT. The accelerations given in the question is 0.4. So this one is 27. So over here we found that this is a 27. Use a proper scale. So over here I just draw with freehand. So I didn't measure it with the proper scale. So I just roughly estimate. Then after that you travel for another 3t second. So you have a 30 plus 3t. Okay, that is a stage 2. So stage 2, no need any calculations. Then stage 4, stage 3. Stage 3 is decelerate at 0.2 second. So your stage 3, stage 2. Stage 3 over here, your V will be equals to the U plus the decelerations of T. Okay, so you will be reaching over here 30 plus 40. Then this answer will be 27 minus a 0.2 T. But they mentioned over here the T less than 30. The T less than 30. So that means over here the T at most it can only be 6. Okay, so at most that means the V must be 21 and above. Okay, V must be 21 and above. Okay, so somewhere around here, we just write over here 27 minus a 0.2 T. So this will be the answer. Okay, so this will be the graph for the part A. Done. Then we are moving on with the part B. The distance of A to B is 2,750. Okay, so the distance total area is equal to the 2750. So we just need to calculate the area formula. The first stage is a trapezium. So trapezium first stage is a half 15 plus 27 multiplied 30. Second stage is the 3t multiplied by 27. And the third stage is also a trapezium. It is a 27 is a half of a 27 plus 27 minus a 0.2t multiplied by t is equals to the 2750. So if we simplify everything, you will get this one as a 630 plus the 81t plus the 27t minus a 0.1 t square is equal to the 2750. So you will be having a 0.1 t square minus the 108t plus the 2120 equal to 0. So we try to factorize it. Okay. So we can actually multiply everyone by 0.1. Okay, so to save time, actually, we just use calculator, press the answer, will do. So over here, you can get the t is equal to the 1060. And another t is equal to the 20. This t is too big. Okay, the t is too big already because this one rejected because of the t is less than 30. Okay, so therefore your answer t must be 20. Okay, so this is the value of t. Now move on with the C. The car continue its journey to decelerate at another uniform deceleration 0.5 meter per second until it comes to rest at the point C on the road. Find the total distance from A to C. So that means if we continue from the graph, okay. when the D is equal to 20, we need to find the, let's say this value is called the W, is equals to the, we are using these equations. We are using these equations. Okay, we are using these equations. Change the D become 20. Okay, so you get 23. So we have a V is equal to 23. So to make our explanation easier, we provide a graph over here, 25, this one 15, 23, 27. So your graph at first is here, here, here. That is the first three stages that we have mentioned just now. And this is the last stage. It will reach to the 0. So we know that this is a 30. Just now, this one is a 30 plus 3t. 3t, the d is a 20. So you get a 90 over here. And this one is plus 110. Okay. But actually, we know that these decelerations, the A is a negative 0.5 meter per second square. Okay. So what you need to do is to find the total distance. Okay. So the total distance over here, we just let the equations W equals to the V minus the plus the 80. So we are having 0 is equals to the 23 minus a 0.5 D, and we can find that the D is a 46. That means this part over here is 46. Okay, 46 second. So we are looking for this area, the distance over here. So therefore, the total distance from A to C, total distance from A to C, A to C. Just now, the first part B, we already know that this part, we already know that this portion is 2750. So we just need to take the is equal to the 2750 plus the last stage over here. It will be half multiplied by the base by the height. Press the calculator, then you will get the answer as 3,279 meter. Done. This will be the answer for the number 4C. Okay, so move on. We have a question number 5. Have a diagram over here shows the one end of a line in extensible string is attached to a particle A is 3 kg. The other end of the string is attached to a particle B of 4 kg. Particle A is in contact with the rough plane inclined at 30 degrees to the horizontal. And the particle B is contact with a smooth horizontal plane. The second line in extensible string is attached to B. And the other end of the string, second string, is attached to a particle C, mass of 5 kg, which is hangs vertically. Both strings are tucked and pass over small, smooth pulleys that are fixed at the end of the horizontal plane. The part of the strings from A to the pulley is parallel to the line of the greater slope of the inclined plane. A, B, C are in the same vertical plane. Okay. The system is released from rest, and in the subsequent motion, C move vertically downward with the accelerations of 2 meters per second square. Neither A nor B reach a pulley. Find the tension in each of the string. So I call this tension tension number 1. I call this tension number 2. Okay, because the C is going down, that means the B will be going this way and the A will be going this way. So at C, if you resolve the forces vertically, it will be the weight of the C, 50 Newton, minus a D1 is equal to the 5A. Okay, but the question mentioned to you that the A is 2. So the T1 is equal to the 50 minus the 5 times 2. That will be equal to the 40 Newton. Then at the B, if you resolve the forces horizontally, you have a D1 minus a D2 is equals to the mass for the B is a 4A. So the D1 is a 40, D2 you do not know. We already know that the A is a 2, then therefore your D2 is actually 32 Newton. So we have found the D1 and D2 done for the part A. Now we move on to the part B. We want to find the coefficient of frictions between the A and the inclined plane. So A is an inclined plane. Lies on the inclined plane. This is a D2. Since there is a rough surface, we must have a R over A here. We have the mass, the weight is 3 kg. So it's 30 Newton over here. Frictional force is going this way because you have a intention. You actually is moving up, so the frictional force will go down. So if you resolve the forces this way, you will get that RA, the angle over here is inclined at 30 degrees. So RA is equal to the mg cos theta. So you get 15 sub 3. So your frictional force will be the mu R. It will be the mu we do not know. So it's a 15 sub 3 mu. Okay, so this is what we have. Then over here, if you resolve the particle parallel to the plane, you will get D2 minus the FR minus the mg sine 30 degree is equals to the MA. So the D2 just now is 32, FR is a 15 sub 3 mu, mg is a 30, sine 30 is a half, then this one is 3, the acceleration is 2. Okay, so from here, just press a calculator. You will get that the 15 sub 3 mu is equal to 11, and the mu is equal to 11 over 15 sub 3. Or you can give the answer in decimal, 0.42339. Okay, I give extra significant figure so that it's more accurate later on if we need to use it. So if it's a 3 significant figure, then the answer will be 0.423. Okay, so I give 2 set of answer. That is the answer for the part B. Done. Now we move on to the part C. When the system has been motions for 1.5 seconds, the string attached to A breaks. The total distance that the A travel up the plane from the instant that the system is released from rest to the instant that the A come to instantaneous rest. So we have 2 stages over here to be calculate over here. We need to calculate the stage 1. Stage 1 is when the string is still have a tension. That means before the strings at A breaks and after the string breaks. So before the string breaks, so you will be having the velocity. So your u is a 0, your acceleration is 2, and the time taken is 1.5 seconds. So you will have the velocity is 3 meters per second. Okay. So for stage 1, that means that your distance travel is S1 is equal to the half of the U plus the V D. Then you will get this one as a 9 over 4 meter. Okay. Now we want to go for after the string breaks. Okay, after the string. After the string breaks, the acceleration is no longer 2 meters per second. We have to recalculate again the accelerations. if you resolve the forces again, then you will have negative Fr minus the mg psi theta is equal to the ma. So your negative, just now we know that the frictional force, this is the frictional force, is equal to 11. So we just need to calculate this one as a negative 11 minus the mg psi 30 degree is equal to the ma. So your acceleration is equals to the deceleration, to be more precise, is a negative 26 divided by 3 meter per second square. Okay, so you will be using the w square equal to the v square plus 2as. You were coming to the instantaneous rest, and the velocity at that time is 3 meter per second. Your acceleration was negative 26 over 3. We have calculated just now, negative 26 over 3. And this is your S2. So calculate the S2, you can get your S2 is equals to 27 over 52. So therefore, your total distance travel is equals to the S1 plus S2. So it will be 9 over 4 plus the 27 over 52. Then you can get the answer as 36 over 13 meter. Just like that, this will be the answer for the question number 5C. Number 5C. Okay. So moving on, we have question number 6. The velocity v meter per second of p at time t second is given as the following over here, where the t is between 0 to 3 inclusively. Find the maximum velocity of p in the interval of 0 to 3. So to find the maximum velocity, we need to find the accelerations. That means we need to differentiate the v, dv dt. So differentiate dv dt, you will get 3 over 2 2t plus 1 power half times 2 minus the 40 by using the chain rule. Simplify them, you have a 3 multiplied by 2t plus 1 power half minus a 40. That is your accelerations. Then in order to get maximum velocity, your dv dt must be a 0. That means the 3 2t plus 1 power half is equal to the 40. And you have a 9 of 2t plus 1 is equal to the 16t squared. Expand, simplify, you have 16t squared minus a 18t minus a 9 equal to 0. Factorize it, you will have 8t plus 3 and 2t minus the 3. So you get the t equal to the negative 3 over 8, which is rejected. And the t is equal to the 3 over 2. That will be the answer for the for the t. But we need to find maximum velocity. That means we need to substitute when the t is equal to the 3 over 2. So your maximum velocity will be replaced inside here. So you will get the maximum velocity is 2 multiplied 3 over 2 plus 1 power half minus a 2t squared. And just use the calculator to help it. Then you can get the answer as this is a 3 over 2, not half. So you will get 8 minus a 9 over 2. That will give you 7 over 2 meter per second. So this is the answer for the question number 6A. Move on, we have a 6B. It is given that in the interval of 0 to 3, the velocity of p is always positive. find the distance of P from A at the instant where the P is moving at its maximum velocity. Okay, so they want to find distance. Since it's always positive, so we do not need to worry whether your area will be negative or not. So we just direct integrate S. To find S, you just need to integrate the velocity 2t plus 1 power 3 over 2 minus a 2t square dt. So you will have 2t plus 1 power 5 over 2 divided by the 5 over 2 times 2 minus the 2 over 3 t cubed plus a c. Okay, so you simplify it first, you get 1 over 5 of 2t plus 1 power 5 over 2 minus a 2 over 3t cubed plus a c. Then when the t is equal to 0, your s is also equal to 0. So it will be 0 equals to the 1 over 5 minus a 0 plus c. So therefore your c is a negative 1 over 5. So replace it inside, then you can get the displacement formula. It will be like this. So now we just need to replace the t equals to the 7 over 2. Then we can find the answer. Oh, not 7. T is not 7 over 2. Just now the velocity is 7 over 2. When you reach to the maximum velocity, your t is supposed to be 3 over 2. So just say that when t equals to 3 over 2, so your distance, it will be 1 over 5, 3 plus 1 power 5 over 2, minus the 2 over 3, 3 over 2 cube, minus a 1 over 5. So you will get this one as the 32 over 5, minus the 9 over 4, minus a 1 over 5. And press the calculator, simplify it, you will get 79 over 20. Or you can give me the answer in decimal, 3.95 meter. Done. This will be the answer for the question number 6B. Moving on, we have question number 7. Per second up and a line of the slope of a rough plane inclined at an angle 30 degrees to the horizontal. The P projected from a point A on the plane and comes to instantaneous rest at the point B on the plane. P then slides back down the plane. The coefficient of frictions between the P and the plane is 3 over 12. Use the energy method throughout. Find the speed of P at the instant it returns back to the A. So we are having an inclined plane. This is the A, this is the B, this is 30 degrees. So you are going up. Your U over here is 8 meters per second. Then this V is a 0. Okay. So then later you're going down. From here, your V is a 0. Then you're going down. At the end, we are looking for the W equal to how much? This is the situations. Okay, so what you need to do is we need to consider the case number 1 and case number 2. Case number 1 is where you go up. Case number 2 is where you go down. That is because we want to know the distance over here. We need to know the distance over here. Okay, so case 1. This is the case 2. So for case 1, using the conservations of energy. Before that, we need to find the frictional force first. Okay, we need to find the frictional force first. So the frictional force, you can see that this is the normal contact. This is your mg, 30 Newton. This is a 30 degree. So if you resolve the forces this way, you will get the R is equal to the 30 cos 30. That will be 15 sub 3. Okay, 15 sub 3, yeah. Then the FR is equal to the mu R is equal to the sub 3 over 12 and 15 sub 3. Simplify it, you will get 45 over 12. 45 over 12 is actually 15 over 4. This is the frictional force. Okay. So now case 1. We are having conservations of energy. So we are having the KE loss is equal to the GPE gain plus the work done by the resistant. Okay, so this is the relationships of the energy. KE loss is a half M of the U square minus the V square equal to the MGH plus the work done by the resistant. The resistant, the distance traveled is D. So we need to find the relationship between the H and the D. Okay, so we know that H divided D is a sine theta. That means the H is actually D sine theta. Okay, so H is actually D sine 30 degree. So it will be half M of the U square. U is a 8. V is a 0. And what is your M? The M is the mass is 3 kg is equal to the 3 times 10 times H. H is a half D. Then the frictional force is a 15 over 4D. So you get 96 is equal to the 75 over the 40. So you get the D is equal to the 128 over 25. Okay, so we found the D. Now we move on to the case 2. Again, conservation of energy. This time you are having the GPE loss is equal to the KE gain plus the work done by the resistance. So the GPE is MGH. The KE gain is a half M of the W square minus the V square plus the FR multiplied by the D. M is 3, G is 10, the H is still same, half D. But the D is 128 over 35. So it's actually half multiplied by the D. This one, the mass is a 3. The W square you do not know. The V is a 0. Plus the work done by the resistance. The work done by the resistance is actually 15 over 4 times the D. D is 128 over the 25. So all you need to do, just need to press a calculator. You will get this one as the 3 over 2 W square is actually equals to the total everything up. Then you will get this as the 45 over 4 multiply by 128 divided by 25. So your omega, press the calculator, you get 6.20 meter per second. This is a 3 significant figure. Okay, so this is the answer for the question 7. Okay, and it's done. Then is the last questions. So I will stop the video here. I'll see you next time, and bye-bye.